Thank you so much for paying attention and digging in this morning as we dug into some really kind of tricky topics around AI, ethics, and innovation. Before we kick off the afternoon, I'd like to spend a few minutes talking about an element that is central to the new value equation, and that's how humanity interacts with technology. Because we're at a very interesting time in that journey. Now, the way that people interact with machines has come a long way in just a few short years. Thinking back to the original human-machine interface, it was not simple, it was not elegant, all right? This is not intuitive, this is not an effective way to interact with technology. Thankfully, things moved quickly and they evolved into something that was much easier to use. Well, maybe not completely easier to use, but still it opened it up to the masses where it's a little more intuitive, you can understand, you can type commands. And as technology continued to progress, we even moved beyond the keyboard and got new ways to input and interact with machines than ever before. Everyone, of course, knows the mouse. Does anyone know what this other thing is? The QCat, which was once described as an object that fails to solve a problem that doesn't exist. It was basically a QR reader before there was such a thing as QR codes. And moving beyond that, we are now in, as everyone keeps saying and as we keep having many conversations about, we are now in the era of voice interactivity, just as predicted by Star Trek IV. And even outside of voice, the interesting thing, the fascinating thing is we're sharing more and more data with companies and with internet providers and with technology providers than many people even realize. And that is a tricky balance to walk when we're talking about PII, when we're talking about people understanding what they're sharing. Because if you went and asked someone, hey, will you carry around this device that lets me triangulate your location at all times and keep tabs on you? They'd say no. But that's essentially what a mobile phone is these days. But it's not just that. You've got typing, you've got voice, you've got image recognition, which we'll hear more about throughout the event. Gestures, authentication, location, motion, proximity, history, all of these are data points that we are sharing as we interact more and more frequently in bite-sized chunks, micro moments, and also as we just don't interact and just exist in ambient technology. What's more, we're even sharing things that aren't as intuitive as just basic data, lat-long location data, what we typed, what we shared. We're actually teaching all of these data collection systems how we respond emotionally to various events. Just think about your social media buttons and how you're able to see something, respond emotionally. That shares that with your friends, but it also shares it with the algorithm. So the algorithm is able to learn in general what emotional response people have, and for specific groups and social network connections, what that emotional response is. For me, the interesting thing about all of these buttons are they're actually also a chronological journey of every time I'm on Facebook. Like this is the timeline as I consume content on my social feed until I just get mad and turn it off. But it goes beyond that because we're more connected than ever before with more devices, more points of interaction. We used to have this challenge where a computer was shared and you didn't know how many people were using it. Now we're having to stitch it together from the other way when there's so many devices, so many points of connectivity that people can interact with in a seamless fashion. This is just a sampling of what an average home has as far as connected devices. Just digest that for a moment. And now I'll reveal that's not an average home, that's actually my home, where 3 people live. An 8-year-old child and 2 adults who often act like 8-year-old children. Within all of this data collection, just as Gerd shared this morning, comes this promise of AI. The more data we are able to collect, the more we can build tools to analyze, to extrapolate, to make predictive models, and to ultimately create consumer-facing applications and new types of interfaces. So it's no longer about understanding how to use the C prompt or understanding how to connect different devices. It's about understanding how to tap into data to create new opportunities for people to connect across devices, across digital experiences. Nowhere is this more evident than in the rise of bots and bot communication. So raise your hand if you remember the first conversation you ever had with a bot. Think very carefully, because I think for a lot of you, it was probably this guy. All right? Why don't you just tell me what movie you want to see? And that was amazing for its time, right? Understanding what we want, being able to respond to that, being able to understand a conversation. But even with the amazing advancements since our friends at MoviePhone, We are still living in the era of weak AI as opposed to strong AI. Weak AI is characterized by being laser focused on one specific task. And it does have superhuman powers to do that task better than any human. But just as Gerd was saying this morning, it can't grow beyond its boundaries. It can't do things it wasn't programmed to do. It can't make intuitive leaps. It can't make connections. It can't understand context outside of what it is focused on doing. It's almost like Dustin Hoffman's character in Rain Man, that has superhuman powers for one specific thing, but can't deal with the fact that he can't watch Wapner or has different underwear. Like that just blows his mind. He can't handle normal human interaction. And so as we think about weak AI, there's actually some really interesting developments and interesting proof points showcasing how weak AI can be surprising and non-intuitive for all of its power. Take, for example, the simple challenge of recognizing and labeling an image. This is something that Google and many other companies have been working on, understanding, being able to take something that's easy for humans to do and very difficult for computers to do. And the technology has come a long way. It's gotten really, really good, but because it is still weak AI, it's missing context more often than not. So if you look at, one moment. There we go. If you look at this picture and you look at it, you can easily see this is a safe falling on a man. Like that's the one sentence description that most people will give. However, if you ask an image recognition AI to describe this, it'll say, I see a door, I see a man, I see a uniform, I see a brick wall, I see a safe. It misses that context of what is implied with the picture that we can put together with our cultural history, with our recognition of everything that's going on, with our assumptions for what's going to go next. But where this really gets interesting is when AI behaves in surprising and unexpected ways. And this can be a good thing because we can learn something from it, but in consumer-facing applications, it can actually be a really bad thing because AI can't understand that context. It can't understand when it is and isn't appropriate to do certain things. Again, it's laser focused on its one task that it's good at, and it's going to keep doing that task because that's what it was told to do. I'd like to say a thank you to Amazon for being a partner, for presenting this morning, and for being a wonderful, just all-around partner to us before I throw them under the bus. This is a tweet that I saw that I found pretty funny, and as an Amazon Prime subscriber, Amazon's algorithms are incredibly good as far as recommended products, understanding my shopping habits, understanding what I care about, but at the same time, there's only so much an algorithm can do without understanding how people use products. Just one more. I'll treat myself. It's a very snarky response here. But Amazon isn't the only company that's struggling with this thing. And in fact, it's not a new problem. It's a problem that's been going on for a long time because anytime an AI of any type, like a bot or a predictive algorithm, interacts with a human, there's an inherent implied judgment. It's saying that at this time, based on what it can recognize, it feels you need this information. It's going to step in regardless of what you're doing, regardless if the context is right or it's an appropriate time to interrupt you and jump in. It sees an opportunity. It flags the opportunity, it jumps in, and it provides what it's programmed to do. It offers its assistance without understanding the implication that that could lead to. No, thank you, Clippy. I would not like your help right now. So in robotics, there's a term called the Uncanny Valley. And that's when an entity, whether it's a robot or a simulation, the closer it becomes to being human, it's very effective until it hits this point where it's almost perfect but not quite. And then we have a very visceral gut reaction of wrongness. Because we can't look at it and say that this is a robot or this is inhuman. We look at it and say it's almost right, and we see that intellectually, but emotionally we have this gut reaction. I think that's very well illustrated in Carrie Fisher here. We've got the young Carrie Fisher, and then we've got the CGI recreated young Carrie Fisher from Rogue One, which is a technological marvel, which is incredible, but also which just isn't quite right on some level that you really can't put your finger on, you really can't define. And the more we work with AI, the more we run into these type of uncanny valley situations where it gets it almost right, where it does, yes, it does what it was asked to do, but because it is weak AI and it's narrowly focused, it's not able to understand the context or understand what exactly we're asking. It's almost like a precocious child, I know you've probably seen these, I've seen these on Facebook shared all the time, of like goofy answers to kids' test questions. Like, for example, there was one that I saw where it said, okay, how do you transform centimeters into meters? And the answer was, remove the CENTI. That is absolutely correct based on the question, but it is not the right answer. And that's what we see a lot with AI today. This was an AI that was given the task of creating names for paint colors. None of these are gibberish, but I think Stanky Bean is one of my favorites. I like Sand Dan. That's a good one. So it was given all this information. It was giving existing paint colors. It was given a dictionary. And it came up with this, which, again, is almost right. But I would say this is an illustration of the Uncanny Valley in AI, where you can't point it. Well, yeah, you can point it and say what's obviously wrong. But, you know, it's language. It's not gibberish, but it sure is not appropriate. And the fact that the AI can't that it spits this out and says, here you go, here are my recommendations. This is apparent in a lot of places when you look for it. There was a group at MIT that was using machine learning to understand new opportunities in robot locomotion. So one of the challenges with robots is teaching them how to walk, building structure that can move itself. And as you see here, this was the solution that it gave. So let me set that up real quick. This was an AI or a machine learning program that had those 6 legs, and they created it and they said, okay, figure out different ways to walk, figure out the most optimized gait, and then they started putting limitations around it. So they said, okay, now figure out how to walk using only 3 of your legs. Okay, now figure out how to walk using jumping, and just seeing what it could come up with. And then they gave it the challenge, figure out a way to walk that minimizes the amount of time your feet spend in contact with the ground. And it came up with this completely optimized solution, where it figured out, yes, this is how I minimize the amount of time my feet spend in contact with the ground. Oh, can we get this to play? There we go. So there you go. It provided the solution for the challenge that it was given. There was another example where they were trying to create an object, a robotic object that could jump. And in this case, they didn't give it a predefined form. They actually gave it a bunch of essentially digital Legos and said, build yourself into a structure with these rules for connectivity and being able to bend and whatnot, and build yourself in a structure that is capable of jumping, and then figure out what structure can jump the highest. And the way they defined jumping was the difference between the lowest point in your structure and the distance that it gets off the ground. So that's the metric of success. Within that context, the AI came back and said, I figured out how to jump, and believe it or not, I figured out to jump so high, higher than my actual body. And the researchers that work on this were a little confused, and so they pulled up the solution, they rendered it, and this is what they saw. First of all, it built itself into this thing, which is just a freaking tower, all right? And then it figured out the most efficient way to jump by the definition of jump given it, remember, the lowest point, the maximum distance off the ground, was to do a not-so-graceful faceplant. There you go. That is how you build a robot that can jump, according to AI and machine learning. My final example is actually my favorite because it's something that's a little closer to what we do every day. This was, again, another group at MIT that was dealing with a very complex set of data. And what they did was they were trying to figure out how to sort this complex set of data and make sure that the output, regardless of how large it was, what type of data it was sorted in a way that they needed to see it and they needed to receive it. And so they gave this machine learning algorithm the ask, okay, go through every possible iteration and let us know when you find a way to ensure we have no unsorted records. Okay, that's the metric of success, that's the description. So if you can think a little bit, thinking like that precocious kid that said remove Senti, the AI actually found out the most efficient way with any data set of any size, of any type of data to ensure there are no unsorted records. It just started deleting all the data. Which, based on the success criteria, was correct. So as we talk about complex problems like that were raised this morning with ethics and AI, that's something we absolutely need to dig into. But the other thing we have to keep in mind is how humanity interacts with these new types of computer solutions, these new artificial intelligence, these new algorithms. Like, they will not, in the current state, expand beyond their program, but they're also extremely literal, and they will do what they're told to do. And so we have to be very thoughtful in what we're telling them to do and how we're telling them to use this information. Because in the era of weak AI, there's no possibility for something like war games, where the computer with the nuclear launch codes played tic-tac-toe against itself until it realized, it drew the conclusion, hey, this is like this, and I shouldn't launch all the warheads. Like, that is an example of weak AI going to strong AI. And in this era, that's simply not possible. And so it's upon all of us to make sure that as we're using AI and machine learning and these tools and these new ways that we interact with technology, that we're using it in a way that is beneficial for everyone, but also that we're using it in a way that's thoughtful. So bringing it back home to the content for this afternoon, we're going to be hearing from a lot of folks talking about where we're going as far as the consumer journey, as far as advertising opportunities, and as far as fantastic new technology that we can leverage to reach your customer, just like Jeremy said, and make sure that we can make them care and deliver a relevant message. But as you're listening to all of this, and as you move forward into this exciting and kind of scary new world, there's two things to keep in mind. The first is that technology enables behavior. Don't focus on the technology itself. Rather, focus on the consumer behavior that the technology unlocks and creates. And the second is that AI supercharges strategy. As hopefully I illustrated with those goofy walking, falling, tumbling AI examples, AI is not a replacement for strategic analysis. What AI is able to do is take these mundane things that take a lot of time, that are difficult for humans to do, transform them, and then fuel our teams and your teams with insights and capabilities that allow us to do more with the things that humans are good at doing. So please keep these two things in mind, and thank you very much for your attention, for your attendance, and look forward to an exciting afternoon.